Hello and welcome back to Mrs. O'Graham's Maths. Today we are doing a worked solution video for Level 3 Calculus from the 2021 paper, and it's the integration standard, so 91579. For question 1, I'm going to start by rewriting this. So we have a third of x plus 3 times 1 over x. Makes it a little easier to see. So if we are integrating, we're going to increase the power by 1 and divide by the new power. So a third divided by 2 becomes a sixth. Then 3 times 1 over x, so the 1 over x integrates to the natural log of x. That's on your formula sheet. And we finish with plus c. For part B, we've got a fairly simple differential equation. I'm going to rewrite it again to make it 8x to the minus 3. Now if we integrate that, so integrate this thing with respect to x, we're going to increase the power by 1, divide by the new power, so that becomes minus 4x to the minus 2 plus c. Now we know that when x is 1, y is 3. So substitute that in and we get the following. So c must be equal to 7 and y is equal to minus 4 over x squared plus 7. Right, question, what's this, B part 2. So it might use a bit of what we've already done. Find the area enclosed by the curve, the x-axis, and the lines x equals 1 and x equals 2. So the curve is y equals minus 4 over x squared plus 7. So to find the area under a curve, we will need to integrate that. And we'll need to do it between these limits that we've been given in the question of 1 and 2. So if we integrate minus 4 over x squared, I'm just going to rewrite that as minus 4x to the minus 2 to make it a bit easier to see. So raise the power by 1, we get minus 1. Minus 4 divided by minus 1 is going to be 4. And then we've got 7x from the 7 and limits of 1 and 2. So if we put 2 into this, we have 4 over 2 plus 7 times 2 minus 4 over 1 plus 7 times 1. And working that through, we get 5 units squared. Okay, part C. This is a kinematics question. We're told all about acceleration and we need to get to displacement. So the acceleration is equal to 2 minus sine 2t. To get velocity from that, we will need to integrate this thing here. So that becomes 2t, and then sine integrates to cos. Minus sine actually integrates to positive cos, so this will become a plus cos 2t, and then the 2 inside of there means we need a half. Here that's reverse chain rule, plus c. Now we look back to the question to find where the information is that we can work out that plus c. So when t is 0, the object has a velocity of 1. So we'll use that one to work out this plus c. So v of 0 is 2 times 0, t is 0, we're just putting that in here, cos 2 times 0 plus c, and we know that's going to be equal to 1. Now we work that through to work out c, and we get that c is a half. Next step is to find the displacement, and we will get that by integrating velocity. So we'll just pop that back in. We integrate 2t, we raise the power by 1, it'll become t squared, that'll get divided by 2, so the 2 cancels. Cos integrates to sine and it remains positive, so that will be sine 2t. We had a half at the beginning, it's now going to be divided by the 2 there, so we will end up with a quarter, and the half integrated will be a half t plus c. So now we look back at the question again, we've got that when t is 0, the displacement is 3. So popping in a 0 into all of this for t, we will have the following. All those zeros cancel everything through, so this C is worth 3. Now, if I'm being picky about this, I should have called these two C's two different things because they're not the same value of C, but anyway, you get the gist. Okay, so now we have that the displacement, we want to work out what the displacement is when the time is 5. So putting in the 5, we're going to do 5 squared plus a quarter sine of 10 plus half times 5 plus 3 equals. Just do that on the calculator, we get 30.36. A quick look up for the measurements we're doing. Displacement will be measured in meters. Okay, last part of question 1, so this will be the excellence. And this question is about proportional growth and decay. Now, the key bit to start with is that we have this sentence here, that the rate is proportional to the square root of the volume of the water in the tank. So we're going to write that down first. So the rate at which the volume is changing over time is proportional to, which means it'll be a constant times by the thing it's proportional to, the square root of the volume. So there's our starting off equation. So we have some mixed in variables there of volume and time. We want to separate the variables. So bring the v, the v over to the left, and we will get 1 over the square root of v. Leave v there, and then the k, we bring the dt up to the right hand side, and we're going to integrate both sides. So the 1 over the square root of v, I'm just going to rewrite that as being v to the minus a half to make it a little easier to integrate. Okay, so if we integrate v to the minus a half, raise the power by 1, we get v to the half. Divide by the new power, so if we divide by half, we will get 2. Integrating k is very simple, it's just going to be kt, and then plus c. Now we have two constants we don't know k and we don't know c, but we've got 2 bits of information up here to help us work that out. So when t is 6, the volume is 400. So if we do the volume in here, 400 to the half is equal to k times 6 plus c. And we can also put in the 10-hour one. So at 10 hours, the volume is 256. Is equal to k times 10 plus c. I'm just going to tidy that up a bit. So 6k, 10k. And you can put that in as simultaneous equations on your calculator, or you can go through and work it out manually. I'll work through a little bit. So this one, the square root of 400 is 20, and if we times that by 4 is 40. So we get 40 is equal to 6k plus c. This one, the square root of 256 is 16, times that by 2 is 32, so we get this much. We can do a subtraction there, so the bottom one take away the top one, and we'd be able to work out what k is, and then use that to work out c. I'm just going to go straight to the answer just for time's sake here. Now, it's tempting to stop these questions when you get down to this point, but make sure we have actually answered it. So the question asks us to finish with how much water was in the tank at the instant it started to leak. So this would be when t is 0. So when t is 0, we will have, so our equation now is 2v to the half is equal to minus 2 times 0, just substituting in that. What I'm looking at here is this equation up here, and I'm substituting in the minus 2, and then substituting in the c is 52. So we have 2 times the square root of v is now equal to 52, and solving that gets us our initial volume of 676 litres. Okay, question 2a, we're back to our achieved. I'm just going to rewrite that second term into powers form here so that it's a little easier to see what we're doing. Okay, so if we integrate that, that'll be a quarter e to the 4x. X gets raised by 1, and then we're going to divide by the new power, so that will end up being 8/3. Okay, 2b, it's a really interesting question, this one. I really like this. So we've got some sort of curve h, and between 1 and 5, it's got an area of 6. That's what it's saying in here. So this area here is 6. Now this bit here is saying take the whole curve and shift it up by 2. So then what would happen is that, so this curve here is going to get shifted up by 2. Now the area that was there was 6. We now have an extra bit underneath of a height of 2 times by the base of 4. So we're just going to add 8 onto what we had. So 6 plus 8, new area is 14. Okay, part C. We're integrating a trig product here that goes sine-sine. So we need this formula. Okay, so we start by simplifying the integral to be, so it's still going to go 0 to pi by 8, but it's going to be cos of, so the a minus b, so 6x minus 2x is 4x, minus cos of a plus b, so 6x plus 2x is 8x. And now we can integrate each of those terms individually fairly simply. One thing I did forget, because this doesn't have a 2 at the front, but our formula does, we need to half everything. So this will be a half of this lot here. Okay, so I'm actually going to take that half out and we'll deal with the rest of the integral. So cos integrates to sine, so that'll be sine 4x and then divide by the 4, minus cos, oops, no, integrate the cos to sine 8x and then divide by the 8, and we're doing that between 0 and pi by 8. So substituting in those values now, it'll be, so I'm actually going to multiply that half through, so we'll get an 1/8 sine of 4 pi by 8 by popping that first one in. And then if we put pi by 8 into the next one, so we've got an 1/8 times a half, so a 16th sine of, it'll be 8 pi over 8, so that's pi, minus putting the 0 in, so an 1/8 sine of 0 minus an 1/8 sine 0. Now all of this is equal to 0 because sine 0 is 0, so we just need to focus on the first bracket. So we have an 1/8 of sine, so 4 pi by 8 cancels to pi by 2. Sine of pi by 2 is 1. This is a 16th of sine of pi. Sine pi will be 0. So we just have the answer of 1/8. Okay, part D, we've got a nice picture for this one. We've got the function 6 over 3x minus 4. We're told that the area of that shaded region is 4, and we need to work out k. I'm going to do this at the side rather than on the lines underneath, just so it can fit all on the screen at the same time. So to find area, we integrate between the limits for the function we've been given for the curve. Okay, so this will, let's take a look. So this will be 2 times the natural log of the bottom, 3x minus 4. If we integrate that between 2 and k, we'll get the area, and then we can set that equal to 4 to work out what k is. So this now becomes 2 log 3k minus 4 minus 2 log of 6 minus 4. and we're told that that will be equal to 4. So I'm just going to work through what that means for k now. So we'd have 2 log 3k minus 4 is equal to 4 plus 2 log 2. Remember, logs are just numbers, so I'm just solving this equation now. This will be 4 plus 2 log 2 over 2. Those 2's are going to cancel, so it'll be 2 plus log 2. To do the inverse of natural log, we take e's of both sides. So 3k minus 4 would be e to the 2 plus natural log of 2. So k will be e to the 2 plus the natural log of 2, add on 4 and divide by 3. Let's pop that into the calculator. We get k is equal to 6.26. If you don't like working it out manually, at this point up here, we could have just put that into equation solver on your calculator to do it as well. And now we have the excellence question for question 2. So we have this diagram here, which is a picture of this differential equation that we've been given just up here. Points P and Q are on the curve and they have an x-coordinate of 3. We want the vertical distance between them. So we need to find the y-coordinate of each of those, and then we can subtract to find the distance between. So we need to solve this differential equation that we've got up here, and we will do that by separating the variables. So we'll bring y over to the left-hand side with dy, and we'll leave the 2 there. It'll be, so since that's over e to the 0.5x, that'll be e to the minus 0.5x to deal with that power, and bring up the dx and integrate both sides. So if we integrate y, we get y squared over 2. If we integrate this right-hand side here, we are going to divide by the minus 0.5. So 2 divided by minus 0.5 will be negative 4 e to the minus 0.5x. And then plus c. Then we need to gather some information to find the value of c. So looking at this curve here, they've given us some specific points like this one here. So when x is 0, y is 1. So over here on our working out, we can put in y is 1. So that'll be a half is equal to, well, if x is 0, that'll be just up here, our x is 0 would give us e to the 0, which is just 1. So that'll be minus 4 plus c. So c is equal to 4.5. Then to work out p and q, we know the x-coordinate is equal to 3. So y squared over 2 will equal minus 4 e to the... Oh, okay, so minus 0.5 times 3 will be minus 1.5 plus 3. Right, sorry, not 3, 4.5 for the value of c. And then we're going to go through and solve this. So I'll just do that now. We get plus or minus 2.686, so the x-coordinate of p will be 2.86 and of q it will be minus 2.86. So then the distance between will be 5.372. Back to our achieved questions with 3a. So I'm going to multiply out that bracket first, so it's x plus root x times x plus root x. So that'll be equal to the integral of x squared plus 2. Now, it's this root x times x thing, so that's x to the power of 1 times x to the power of a half. So that'll be x to the power of 1.5, or 3 over 2. And then x, the root of x times the root of x is just x. Now integrating that, x squared becomes x cubed over 3. This will be x to the 5 over 2, and then 2 divided by 5 over 2 will be 4 over 5. X becomes x squared over 2 plus c. All right, question 3b is trapezium rule, which is a very boring, but here we go. So here it is from the formula sheet. So h is the gap between our intervals like this. So h will be equal to 0.25. So the integral 1 to 2.5 of f of x dx is going to be a half times 0.25 times by, so over here we've got the first y term, so that's 0.8, plus the last y term, 2.4, plus 2 times all of the others. And that comes to 2.6. Okay, part C, we've got this differential equation. We're going to need to separate variables because we've got the y's and the x's mixed up, so we'll start there. Y over to the left, sec squared 2x and dx on the right. Integrate both sides, so we get y squared over 2. Look on the formula sheet for sec squared. Sec squared integrates to tan, and then because of the 2 inside it, we will divide by 2, and then plus c. So we'll use these values that we have up here. So y is 2 when x is 3 pi by 8 to work out the value of c. So if y is 2, then 2 squared over 2 would be 4 over 2, which then cancels to 2. Half times tan of, well, 2x would be 6 pi by 8 plus c. So 6 over 8 cancels to 3 pi by 4. Tan of 3 pi by 4 is minus 1, so this is minus a half plus c is equal to 2. Therefore, c is going to be 2.5. So finishing off the question, find the value of y when x is pi. We have this, so work it through on your calculator, and we will get y is equal to plus or minus 2.236. Part D is finding this shaded area here that's underneath of this curve here, but we don't have the x coordinates, so we'll need to use the y coordinates to work them out. So I've just done that quickly, setting the y equal to 1 and y equal to 2. We get x is 2 and x is 6. So now we're going to integrate that function between 2 and 6, and it was 3x minus 2, x plus 2. Okay, first thing is to sort out that fraction there. We can't integrate it as it currently is. So I'm going to do a bit of algebraic juggling with this one, putting it as the factor of what's on the denominator. You can take a look at my playlist of integration videos for this method I'm using at the moment called algebraic juggling. So that would become 3x plus 6. We want it to be minus 2, so we need a minus 8. So that'll be this x plus 2's cancel, and we get this. Okay, so if we integrate 3, we get 3x. 8 over x plus 2 will be minus 8 log of x plus 2, and we're doing it between 2 and 6. So we've got, putting the 6 in, we get 18 minus 8 log 8, minus 6 minus 8 log 4, and you just type that into your calculator. You get 6.455. Okay, for our final excellence question on this paper, we've got this graph. We've got these two equations that says, this is the equation of the curve, this is the equation of the line, so this is y equals k. So this coordinate just here will be k at that point just there. So this is y equals k. Okay, so to find the shaded area, we want the area under the curve. We will need to know what this coordinate is here, so we're going between this coordinate and 0. So we need to know where those two lines meet. So if we do k e to the x squared is equal to k, we can work out those points of intersection. So I'm just going to pause and work that through. So this coordinate down here is a funky looking one. half the natural log of 1 over k. Now we can go about doing our integration to find the area under the curve. So the area will be between half natural log 1 over k and 0 of the equation of the curve, which was k squared e to the 2x dx. And we just need to remember that will give us the shaded area that includes this bit here as well. I'm going to take that off at the end, so I'll come to that in a bit. I just need to remember not to miss that step at the end. Okay, so if we integrate k squared e to the 2x, remembering k is just a constant, so this will be half k squared e to the 2x, because e doesn't change, but the 2 will come out as a half. And then we're going to need to put in our limits, so half natural log 1 over k and 0. So that becomes half k squared e to the 2 times 0, so that'll be e to the 0, which is just 1. Take away half k squared e to the 2 times half log 1k, so that'll just be log 1 over k. Well, e to the log of 1 over k, that cancels. So this will be half k squared times 1 over k. Right, so that would give us the area under the curve, which includes this bit up here, remember. So we now need to take away that little rectangle portion. So the area would equal this minus the area of this rectangle. Now the height of the rectangle is k, and the base of the rectangle is the distance between 0 and this coordinate here, so that will be half natural log 1 over k. Now if we tidy that up, we can take out a factor of a half k from all of that, and we will get, from this first term here, we need another k. We've got a half k in the second term, so that's just 1. And then at the end here, if we take out a factor of a half k, we have the natural log of 1 over k, as was required. So we are all done.